Here's an extra practice on 7.2 and 7.3. So you need to make sure you know how to graph these rational functions. You can use a calculator, but before we even pick up a calculator, you should be able to identify the vertical asymptote, the horizontal asymptote, and your domain and range. So I can tell right away, I see an x minus 2. I know positive 2 would give us an error. So I know we will have a vertical guideline. So I'm going to just draw this in, a vertical guideline when x equals 2. Okay? We also can see that this is shifted up 3. So instead of having a guideline at 0, we're going to have a guideline at y equals 3. So y equals 3. And if you have, oops, I move this down. Here's my guidelines. And then domain, all reals, except this right here, which is a 2. And your range is going to be every y value there is, every decimal, every fraction, except a positive 3. Okay, so again, you could do all that before even picking up a calculator. And then just make sure you type it in the calculator correctly. So I like to use parentheses. You have to let the calculator know it's dividing by the quantity x minus 2. So x minus 2 needs to be wrapped in parentheses. And then we're shifting up 3. When I hit graph, I can see it's going to be in this corner and up here. And I just need to go to my table. I'm going to plot some nice dots. I'll plot 0, 2. And we'll plot 1, 1. Okay, that'll take care of the left side. Just try to follow your guidelines, go through your 2 points, and show that it's going to continue to get closer to that outcome of 3, but never become an outcome of 3. It's also getting closer to an input of 2. And as you get closer to an input of 2, 1.999, your y values are getting smaller and smaller. It goes down forever. Okay? So now I need to just do 3, 5. So 3, 5, there's a dot. And we'll do 4, 4. Okay? And that's all the information we need to sketch a graph of a rational function. Okay? So here I have the different form. We have x's in the numerator and in the denominator. So I am going to ask you to do long division. So I'll quickly do long division. It should take you 2 moves. Okay? X into 2x goes twice. And then you multiply 2 times x, line everything up. 2 times the 2 is a 4. And you just switch it to its opposite. And you're going to see you have a remainder of -1. So you write the remainder over the denominator. Okay, so if I rewrite this, this is fine. That's all I would need to see on your quiz. But I'm going to write it as -1 over x plus 2 plus 2. Okay, now it looks like number 1. So now I'm going to see that it's a reflection. My vertical asymptote is going to be x equals -2, okay, whatever causes the denominator to be 0. So in this case, a vertical guideline at -2. I'm shifting up 2, so I'm going to have a horizontal guideline at y equals +2. So my domain, use any number you want. We're going to see there's an error at -2, and all our outcomes are going to be everything except +2. Okay? So I'm going to type in my original function. That way, in case you mess up dividing, you could type this in as well, but if you made a mistake, you're not going to get the correct graph. So I'm going to type parentheses 2x plus 3 divided by the quantity x plus 2. Okay, so again, it's very important that you realize these need to be in parentheses. Okay, so even over here, I'll put this in parentheses so you can see. That's how we have to type in our calculator. You can hit graph. Now we're in these 2 corners because it was a reflection. And I just need to go to my error. And we'll plot -3, 3. So -3 up 3. I can do some other, I could estimate where 2.5 is. right about there. So again, just follow your guidelines, and we're done with that half, and we'll do -1, 1. So right about there, we'll do 0, 1.5, and just connect, and you're done. Okay, so again, show the arrows so that you can see that it's good. The graph is following those guidelines. Okay, so that's how you graph rational functions. Two cases, so case 1, case 2. Okay, the rest of this is all about factoring, canceling out factors, never terms. Okay, so for this one, you want to start by factoring the numerator. All you have to do is factor out a GCF of 2. So it's going to be k plus 4. And then on the bottom, pretty easy trinomial to factor. Everything's positive. Weighs again 20. I know it's going to be a 4 and 5 to add up to a 9. And the good news is we have something in common. We have factors in common. Cross them out and write what's left over. Okay. So then, since I crossed out the k plus 4, we're supposed to state the excluded values. K can't be -4, and it should be obviously that it can't be -5 as well. So I'm going to put both exclusions. Okay, but it's obvious that someone can't substitute a -5 in there because we still see it. Okay, number 4 is very similar. Factor out the GCF. The bottom, another easy trinomial to factor. One's plus, one's minus. For it to add up to a -1, I'm going to need a -2 and a +1. And just like last time, factor cancels out, and you get this answer. Okay, don't be tempted to think that you could reduce this. That is a term. It's a -2, cannot cancel it out. So you're done there, and just let someone know, can't use -1 and a +2. Okay, that would cause you to divide by 0. Okay, and then this, our trinomial now is on the top, so we'll factor the top, r and r plus minus. I'm going to need to get 27 to add up. I don't know why I said it's minus. I'm sorry. It's a positive 27, so the signs have to be the same. They have to add up to -12, and it's going to be 9 times 3. Okay, that's what checks to get us back to that trinomial. And r minus 3 is on the bottom. That stays together, but the good news is they get wiped out. So final answer is simply r minus 9, and r cannot be a +3. Okay. Last regular fraction, then we get into multiplying and dividing. Here, the 36 is simply a 36. But then down here, I can factor out the GCF, which is going to be a 12. So I factor out a 12. I'm left with x minus 2 in parentheses. And we can now reduce. These are factors. A 36 over 12 is a 3. And then you have an x minus 2 in the bottom. X can't be a +2. Okay, so 3 over the quantity x minus 2 is the simplified version. Okay, so again, that's just factoring the numerator, factoring the denominator, and canceling out. Now, with multiplication, we just have more parts to factor. Okay, so we need to factor each part of this and then cancel out anything between the top and bottom. Okay, so 2 sets of parentheses. This time it's a plus minus. I know it's going to be a -10 and a +9. Here all I can do is factor out a 3b, and I'll have a b plus 9. And then this numerator, we can factor out a 3b, and you're going to have v minus 8. And then here we can factor out a 4b, and we're going to have v minus 10. Okay? So again, just make sure you know how to factor. We've been factoring all year long. And once everything is factored, anything between the top and bottom. So cross that out. This v is a factor. We'll cancel out that v. This 3 will be wiped out by this 3. So it looks like we are left with v minus 8 up top. So the only thing remaining up top is a v minus 8. And in the bottom, we have a v and 4. So that's really a 4v. And that's it. So with number 7, you're left with v minus 8 all over a 4v. And they don't tell us to list the excluded values. So you're done with that expression. Okay? Here we have a division problem. So division is really multiplying, but we must flip this second fraction. It's the reciprocal. So this right here, we factor out a 5x squared. That's the GCF. You're going to be left with x minus 2. In the bottom here, we can factor out a 5x squared again. Hey, these 5x squares are going to cancel out. And you're going to be left with x minus 3. Okay? Now, this denominator is now my numerator, so I'm going to factor this. It's going to be x minus minus, ways of getting 3. It's going to be a 3 and 1. And now this goes in the bottom. It's x. It's going to be a plus minus, ways of getting negative 10. It's going to be a 5 and a 2, so it adds up to a 3x. So now all I have to do is look for things that are factors in common between the top and the bottom. Okay? And write what's left over. So in this case, you're left with an x minus 1 over an x plus 5. Okay? Pretty easy. Okay, easy if you know how to factor. Another division problem. Don't change the first fraction. Okay, so I'm going to factor out, actually just factor x plus, ways of getting 36 to add up to a 13. It's going to be a 9 and 4. Okay, again, your brain that may take you a while, but you need to know your times tables. Here I'm going to factor out a 5 first. So I'm going to factor out a 5, and then you're going to have x squared minus 2x plus 1. And then we can factor that then. So I'll factor that after I flip this. I'm going to factor out another 5 here, and we'll have x squared plus 3x minus 5. And then this goes to the bottom. Okay? So I'm going to factor the trinomials now. I'm just going to rewrite the top. And now I'm going to do x minus 1, x minus 1. Okay, that's how you factor that trinomial. Here we need an x. Let's see, ways of getting 5. Can that be factored? Oh, I forgot a 2. So that's going to be, this is going to be the AC method. Sorry, up here I did not factor that correctly. So now I'm going to factor this. I'm going to make a little diamond, and I'm going to think of ways again, negative 10x, because it's 2 times negative 5 to add up to a 3. So this is going to be a positive 5x and a minus 2x. Okay? So just to save time, you would do this off to the side. You would split it down the middle. But I know it's going to end up being, this is actually going to be, I made a mistake. I'm trying to go too fast. Sorry. I'll do this right here. I'll split it down the middle right here. Okay. So if I split it down the middle, all I can do is factor out an x, and I'll have a 2x plus 5. Over here, I'm going to have to factor out a negative 1, 2x plus 5, and that's going to result in an x minus 1. And then the other factor is a 2x plus 5. Okay? So that's fully factored, and then you have your 2x plus 5 in the bottom. Okay? So once you have fully factored correctly, and again, this type of work can be done off to the side or on another piece of paper, but I had to factor the trinomial, and now look for things in common. So So this gets wiped out by this. This wipes out that. And the 5s are factors. They get wiped out. So it looks like when all's said and done, I'm left with an x plus 9 up top. I still have the x plus 4 up top. And in the bottom, I have an x minus 1 that wasn't canceled out. And there's your final answer. Okay, so x plus 9, x plus 4, all over an x minus 9. Okay, so for this one, number 10, start with a GCF. So this numerator I can factor out a 10, 5n minus 6. Here, stays together. Can't do anything with a 6 or 7n plus 6. I can flip this, and this goes on top. I'm going to factor out a 2. So you're going to have 7n plus 6 inside. And up here, I can factor out a 5, 5n minus 6. Okay, so again, that one was pretty easy. Just factored out GCFs. This wipes out this. This gets this going. I can reduce, before I multiply 20 over 5, I can reduce 10 over 5 is really a 2 over 1. So that whole ugly thing comes out to a 4. Okay, so that's just telling you, you plug in a number in for n, you calculate it, you know your outcome's going to be a 4. Your outcome is always 4. Okay? 2 more. Here we're back to a multiplication problem. So you want to factor out a 10n, so n minus 2. And then down here, your GCF is going to be a 7. So we're going to have a 5n minus 3. Okay? So now I'll have to do the AC method for this one. This is going to take a moment to factor. So I'll come down here, I'll factor this, I'll factor out 10n, and we'll have n minus 2. Okay? So now, this is where you're going to have to do some work. So I'll show you. We need to take 5 times negative 21. So we have a negative 105 n squared, and we're not going to give up until we find a combination of numbers that can give us the 32. Okay? So you can start dividing. You know, your signs are going, one's going to be positive, one's going to be negative. Okay, so I'm going to 105 and 1, that's not going to work. 2 doesn't fit. You can divide by 3. And as soon as you do that, I'm hoping your brain sees a 35 and 3, the difference is 32. Okay, so I didn't show that, but I divided by 3. And so I know I can break negative 105 up as 35n minus 3n. Okay, so I'm going to do 5n squared plus 35n minus the 3n and then minus 21. Split it down the middle. On this side, I factor out a 5n. I'm going to have n plus 7. I need to factor out a negative 3, but I'll have that n plus 7, so I know I factored correctly. So it's going to be a 5n minus 3 and an n plus 7. Okay, again, harder trinomial factor, but we've been doing those problems all year long. Break them down, do this work off to the side, you'll find the pieces. But now, once everything's factored, it's easy. Cross out the common factors. 5n minus 3 gets wiped out by that 5n minus 3. The n minus 2's get wiped out. And when all is said and done, you will have an n plus 7 up top and a 7 on the bottom. Okay? Good problem. And finally, the last problem, we can factor out a 4n. It's a multiplication problem, so nothing gets flipped around. We'll have an n minus 5 in parentheses. And then here, we can only factor out a 2. So I have n plus 6 inside the parentheses. That stays a 4. We'll factor out a 4n. And when we factor out a 4n, we'll have n minus 5. Okay? So now, cross out. Looks like the n minus 5s cancel out. This 4 will be wiped out by that 4. They're factors. This n can be wiped out by that end. So it looks like when all set, and I can also reduce the 4 over 2. So 4 over 2 is really a 2 over 1. So when you look at what's left up top, you have a 2 up top, and the only thing remaining in the bottom is an n plus 6. Okay? So that's what I need you to be able to do from section 7.3. So 7.3 is all about canceling factors, never terms. Okay, so make sure you have that ability to factor correctly. If you make a mistake, just learn from it. Check your answers. Try that big idea assignment, and you should have plenty of practice to perfect this. Okay, so thanks for watching. That took 20 minutes. Take care.